Hello everyone and welcome to today's Hydrogen Safety Training webinar. My name is Molly Putzig. I'll be the moderator today. And I just want to start you off with a few housekeeping items. First, I want to let you know that everyone is in listen-only mode, but if you turn your attention to the chat box on your control panel, you can use that function to ask any questions or make any comments you want throughout the webinar, and we will have a question and answer session at the end. We'll get to all the questions that we can during that time. And now I'll turn you over to Carl Rivkin.
Good morning and good afternoon for some of you. I'm Carl Rivkin. I work at the National Renewable Energy Laboratory here, primarily working on hydrogen safety projects, work to further the deployment of hydrogen and other alternative fuels. And today, what I'm going to be talking about is some aspects of hydrogen safety. I'm going to be primarily focused on the codes and standards required to review and approve hydrogen projects, and that focus is based on the direction that I've got from the National Park Service, specifically Raul Castillo from the National Park Service. And I want to thank Raul for helping me put together the structure of today's presentation. To give you a little bit of background of some of the products I've worked on relevant to what I'm talking about today and my experience. First of all, I worked with the National Park Service on the Brentwood Hydrogen Fueling Station project. And for those of you who aren't familiar with the project, basically what it consisted of is taking a modular hydrogen fueling station that was located at in Connecticut and moving it to Washington, D.C. to the National Park Service Brentwood site. That's a repair maintenance facility in Washington, D.C. And locating this modular station there, so it meant connecting it to the utilities there and siting it according to the requirements for siting hydrogen storage and dispensing. So when I worked on that project, I got a chance to meet some of the National Park Service fire safety people, and from that experience, this webinar has followed. I've been working on hydrogen safety issues for quite some time. Prior to joining NREL, which was about 10 years ago, I worked for the National Fire Protection Association for almost 10 years. And one of the projects I had at the NFPA was developing a national code for hydrogen safety, and that national code is NFPA 2, the Hydrogen Technologies Code. So I worked on that when I was in NFPA, and then after leaving NFPA and joining NREL, I've actually assumed the position of the chairman of the NFPA's Hydrogen Technologies Technical Committee, and so I'm now the chair of the NFPA 2 project. So it's kind of an interesting transition from creating a project to now managing the project that I started. Sorry, we had a little technical glitch here in advancing the slides. My apologies. What you should be seeing is a course outline, and I'm going to talk about what we're going to cover today. The plan is for me to talk for about 40 to 45 minutes going through these slides, and then we should have about 15 minutes to field questions. But if we don't get a chance to address your question, please send it to us, and we'll get back to you one way or another. First, I'm going to give an introduction as to why this topic is important. Next, I'm going to talk a little bit about some of the basic hydrogen properties and hydrogen safety. Then I'm going to talk about this Hydrogen Technologies Code, because for those of you who are in a position of, and you may be someday, of having a hydrogen project to review at your site, there are a lot of codes and standards that in some ways touch on hydrogen. NFPA 2 is meant to be that central code, and it is that central code that you start with, and from that you'll find the key requirements that you need and the references to the other documents that may have a role in your project. Next, I'm going to talk a little bit about how to actually apply this NFPA 2 hydrogen code to a hydrogen fueling station, and I'll be using some examples from the hydrogen fueling station that NREL runs here. We have both a high and low pressure vehicle hydrogen fueling station at this site. And then I'm going to talk about some of the permitting tools that the Department of Energy has supported and are readily available through several websites. And also should mention that this presentation will be posted at a couple web locations, so it should be readily accessible for those of you who want to take a look at it or use it for your own purposes, for your own projects. And then I'm going to conclude with a little summary, and we'll take questions. Before I get into the actual material, I'd want to thank Rachel Shepard at the U.S. Department of Energy for supporting this work, and all the people in the FEMP program who've made this presentation possible. So first, why are we doing this seminar? The reason is that a large-scale deployment of hydrogen technologies is something that very likely will happen. We're just starting to see the first commercial deployment of hydrogen fueling stations and fuel cell vehicles that are available in retail sales locations at car dealerships. But if you look at this bar chart that was put together by the International Energy Association, what you see is that a really major progression and increase in hydrogen fueling stations over the next several years. So we project, or they project that by 2025 there will be about 600 hydrogen stations in the United States. By 2030, over 10,000 stations. And by 2035, 15,000 stations, and by 2050, close to 30,000 fueling stations. So what does that mean? It means that there will likely be a hydrogen fueling station at a National Park Service site or other federal sites. And there, as I mentioned, there is a hydrogen fueling station at the NPS location in Washington, D.C. And I believe there's a fueling station at a post office outside of Washington, D.C., a distribution center. And there have been, just to give you a little background, historical background, there have been hydrogen fueling stations to support industrial trucks, forklifts at other federal sites, at DoD sites in the past. So these projects are, although there aren't that many of them, they're in some ways prototypes, they are starting to happen. And given that the deployment of hydrogen looks like it's moving forward, specifically the deployment of hydrogen fuel cell vehicles, it's likely that you'll see some kind. You may see a project at your site. So the purpose of this webinar is to kind of give you an orientation, so that if that happens, you have an idea of what this technology is about, and how it's regulated, how the codes and standards apply to these fueling stations. So a little background on hydrogen. Why is there this interest in hydrogen? It may seem a little bit unusual because right now there is not a retail infrastructure for distributing hydrogen, and there is not the kind of hydrogen production that will be needed for widespread deployment. So there will be a lot of infrastructure that is needed. So why is there this push to do this? And there are several reasons. One is hydrogen is an excellent fuel for fuel cells, and fuel cells produce almost no hydrocarbon emissions. So it's a zero emissions technology, zero carbon emissions technology. Another really critical point is that hydrogen can be produced from a variety of renewable energy sources, such as wind power, solar, biomass, and some of these technologies are very well developed, and they're fairly mature technologies. So what you can do to address this gap in hydrogen production is use some of these renewable technologies, such as wind and solar, to produce large amounts of hydrogen. And one of the key characteristics of hydrogen is that it can be produced from electricity and water, and you see that the equation there where you put electricity and water together, you get hydrogen and oxygen. But then you can also, with that stored hydrogen, by adding oxygen and running it through a fuel cell, you can produce electricity and water. So what that means is that hydrogen gives you the ability to store what amounts to large amounts of electricity indefinitely and convert that hydrogen to electricity when it's needed. And that conversion can take place on a vehicle. That's what the hydrogen fuel cell vehicles that are now being sold do. They take hydrogen and they convert that hydrogen to electricity that powers an electric motor on the vehicle. So this flexibility of hydrogen is really very important and one of its more desirable attributes that is pushing it forward. So a little bit about air pollution and how important it is, and maybe it doesn't rise to the top of the list as far as topics in the news, but this is, I just took this little snippet of information. In 2002, there were 6,500 premature deaths from air pollution in California. And to put that in perspective, there were 3,500 fire deaths nationally. So in the whole United States, there are far fewer fire deaths than there were deaths from air pollution in one state, California. And the United States has, even in areas where there's major vehicle density, still has relatively clean air. So this air pollution problem that is causing premature death is much worse in other locations. Probably many of you have seen pictures of Beijing and have a sense of what the air quality is there. So to address this problem in the United States, there are actually regulations that have been put in place to not just encourage, but actually require the sale of zero-emission vehicles. And it's not the entire country, but what you see here are the so-called zero-emission vehicle states. California is one of them, but there's a whole cluster of those states located on the East Coast. As a result of these regulations, the deployment of hydrogen fuel cell vehicles has happened in California initially, but it is also underway in this northeast corridor. There's stations being built in Massachusetts, Connecticut, New York, and I believe Rhode Island, to create a network of stations on the East Coast so that vehicles can transit the coast and still have fuel available. In California, there's a network of stations. I believe there's 30 retail stations open now that allow you to use a hydrogen vehicle throughout the state of California. So a little bit about the properties of hydrogen. Just to make it clear, hydrogen it's not new as far as it's being used with hydrogen fuel cell vehicles. It's been around quite some time. As far as a commercial commodity, there was a process developed in 1913 by the German chemist Fritz Haber to make hydrogen from ammonia, and this had a huge global impact because what it allowed for the mass production of fertilizers that were required to feed people, and it resulted in literally millions of people getting food who wouldn't have without this fertilizer to expand crop growth. But hydrogen is also used in a lot of other industrial applications, and you see a few of them listed here. if we lost, we skipped a slide here. Yeah, just want to mention this is an example of the historical use of hydrogen. This is a handbook on industrial hydrogen that was published almost 100 years ago, and actually a lot of the information there is perfectly valid today. Now I want to get into a little bit of the properties, the physical properties of hydrogen, because hydrogen really has some unique characteristics, and it's important if you're dealing with a hydrogen project, particularly if you've got safety responsibility, to understand some things about hydrogen that make it different than other materials and other gases that you might have to regulate. First of all, hydrogen is it's the lightest element. What you see in that second column is that as it has a specific gravity of 0.07. That's the density relative to air. So what that means is that if you release hydrogen into the air, it goes upwards, and it goes upwards very quickly. Hydrogen, unlike some other gases and fuels, can't be odorized. As a result of that, sensors are required to detect hydrogen releases at locations like fueling stations. Other fuels like natural gas, you can add mercaptans to them, and that way you can smell any release. Hydrogen has a fairly wide flammable range. That doesn't have as much safety impact as the fact that it has a very low ignition energy. That you see that 0.02 millijoules. So what that means is if you do have a hydrogen release, if it is not immediately ignited, it probably will just disperse upwards rapidly. However, it does not take much energy to ignite it. So that kind of gives you a little bit of a picture of what you're dealing with. Some more aspects of hydrogen. Because it has very low density, it has to be stored at high pressures. So to have enough hydrogen to give a vehicle a required travel range, you really have to up the pressure on the vehicle storage to get enough hydrogen on the vehicle. But that means that pressures of 10,000 psi are used on vehicles. Those are the passenger vehicles that are currently being sold. And the fueling stations have to be able to go above 10,000 psi to drive that hydrogen into the vehicles. Hydrogen, because it's a very small molecule, it can attack materials in ways that other gases can't. So there's the kinds of materials that are used for hydrogen storage are very specific. There are certain materials that can't be used. And as I mentioned, hydrogen can't be odorized, so you need to have sensors in the environment where the hydrogen is used to detect any potential releases. Hydrogen has essentially no environmental impacts. It's not toxic. So if there is a situation where hydrogen is released and it isn't immediate, there isn't some immediate ignition, and there's nothing to contain it, it will typically it will go upward very quickly, dissipate, get out of the flammable range very quickly, and there's no action required. So from that, what follows is this last statement that safe designs involving hydrogen fueling stations and other hydrogen technologies should not impede the dispersion of hydrogen, because that's really one of the main safety attributes of hydrogen, is that you do have a release, it's going to be gone quickly, and it will not be in the flammable range very long. So how does this compare to some other fuels? Pure hydrogen burns with a nearly invisible flame and low radiant heat. So if you're confronted with a situation where there's a hydrogen fire in broad daylight, you may not be able to see the flame. You may have to use some kind of detection device if you think there's actually a fire. And because it has such low radiant heat, you will not feel the heat of the flame until you're almost on top of it, which makes it a lot different than than hydrocarbon fires. And as a comparison to, for example, propane, a propane release will actually, because propane is denser than air, will migrate downward, and it can be retained in below-grade spaces. And you can have propane in a below-grade space in the flammable range retained for years, and then you somehow open up that space, ignite the propane, and you have a fire. So that kind of situation won't occur with hydrogen. And another thing that won't occur with hydrogen is if you have release, there's nothing retained. So For example, with gasoline, if you have a gasoline spill out of a tank, and this is fairly common with older gasoline tanks where the tank, below grade tanks have degraded, there's been release from gasoline, soil contamination, and you see a picture here of tank replacement operation in place, but that's something that will never happen with hydrogen. If it is released, it's not going to contaminate anything. Now, I mentioned that because hydrogen has such a low density that to get the required amount of hydrogen for applications, you're going to need to get that hydrogen up to a very high pressure. And what also follows from that is that to get the kind of storage amounts you need, having a lot of high pressure tanks may not work, and that therefore you're going to have to consider the possibility of liquid hydrogen storage. And liquid hydrogen is really an interesting material to deal with because it boils at minus 423 degrees. It is extremely cold. So it takes a lot of energy to liquefy it. It has to be stored, of course, in a cryogenic vessel, which has it's really two vessels, and there's a vacuum drawn between in the interstitial space between those two vessels. But even with the dealing with liquid, the liquid density of hydrogen is much lower than other liquids. So I have what I think is a little interesting fact about hydrogen. There's more hydrogen in a gallon of liquid water than in a gallon of liquid hydrogen, because the density of a gallon of liquid water is much higher than a gallon of liquid or water or hydrogen. But one really important point to keep in mind if you're dealing with these systems is that even though the hydrogen is extremely cold, it's a liquid, if it's released, it is going to vaporize almost immediately. That's actually, that last statement should say vaporize when it's in the contact with air. So if you had a tank where it somehow was punctured, a liquid hydrogen tank, it'd be unlikely that it would actually spill liquid hydrogen on the ground. What would most likely happen is the hydrogen would rapidly vaporize. You'd see a cloud of condensation from the liquid in the air, the water in the air being liquefied, but the hydrogen would likely not touch the ground. It would also disperse rapidly upwards. So that's something to keep in mind if you're dealing with a liquid hydrogen storage system, that it's unlikely that liquid hydrogen would ever touch the ground, and these systems are constructed without berms to contain any liquid spills, unlike petroleum storage systems. Now let me move on to NFPA 2, the National Hydrogen Code. As I said, it's been designed specifically to be this kind of central repository of hydrogen requirements. So it's the code you can start with, and it will pretty much point you to all the different requirements you need for whatever project you're dealing with. Want to make it also clear that this NFPA 2 is referenced in the two major fire codes that are used in the United States, the NFPA 1 Uniform Fire Code and the International Fire Code. So as a result of the fact that it's referenced in those codes, it is effectively the law in all jurisdictions in the United States where one or both of these codes is invoked. So that means legally it is also really the national code. And as I mentioned, covers almost all aspects of hydrogen safety, and it references many other documents, including component standards. Little picture of what the structure of NFPA 2 looks like. You see that these are just from the table of contents, the different topics it covers. And it's the way it's structured, like many NFPA documents, is it has a set of general requirements up front, and then you get into more specific requirements like requirements for bulk gaseous hydrogen storage and bulk liquefied hydrogen storage. And then one of the chapters I'm going to spend a little time on is Chapter 10, which is really the chapter for hydrogen fueling stations. But I also should mention it covers other facilities, for example, repair garages, because there are already repair garages that are being modified to accommodate hydrogen fuel cell vehicles. So just to, in going through the code, I thought it'd be helpful. Sorry, I had a slide jump there, but we're back on the correct slide. In going through some of the code requirements that address a hydrogen fueling station, because I think that would be that's probably the project you're most likely to see first, a fueling station. Thought I'd give you a picture of what is a hydrogen fueling station, because it is a little bit different than a gasoline station, although I mean it has a lot of the same basic pieces. So what you see here are really the three, and you can break up the station in different ways, but this is a simple way to give you a picture of what the station consists of. First of all, you have storage. You have to store the hydrogen on site, and that's even true even if you have the ability to produce the hydrogen on site. You still have to store it. There are some stations that do produce hydrogen on site. Other stations have hydrogen trucked in. Some stations actually connect to hydrogen pipelines, but they all have some type of hydrogen storage. That storage could be liquid and gaseous storage, but it is going to at least include gaseous storage. And the reason that's the case is that even for stations that have liquid storage, that liquid hydrogen is vaporized and then compressed and dispensed into the vehicle as a gas. So right now, all the hydrogen fuel cell vehicles out there are getting gaseous hydrogen at the dispenser. There is I mean, it's not impossible to put liquid hydrogen on a vehicle, but that is not the initial technology that's being deployed. So you have storage, then you have compression. You've got to up the pressure of the hydrogen so that you get it up to that 10,000 psi that is required on the vehicle. So that means you're actually compressing it a few thousand psi above 10,000 at the station. And then you've got a dispenser, and dispensers typically have a chiller at them. You have to cool the hydrogen to achieve the desired fill time for passenger vehicles. So you can dispense the hydrogen without chilling it, but the fill time would be much longer. And the goal right now is to replicate the experience that for filling a conventional vehicle. So filling a hydrogen vehicle takes about 4 or 5 minutes, which is roughly the same as what it takes to fill a conventional vehicle. So anyhow, there are these 5 chapters that I've identified here that deal specifically with, and generally with hydrogen fueling, and I'm going to talk a little bit about them. First, chapter 4 has just a set of general requirements that kind of cut across all applications and installations, and these are things like if you have to get a permit, it tells you what you have to do. Emergency plan, what has to be in that emergency plan, what are the criteria for facility closure, management plan, what kind of personnel training is required, signs, protection from vehicular damage. Next, you get to chapter 6, which is the general hydrogen requirements. So this gets into more hydrogen-specific general requirements, things like that may not apply to all these may not apply to a fueling station, but some of them do. And there's things like requirements for fire alarms and gas detection. Some of these requirements, for example, for gas cabinets, you're not going to have a gas cabinet typically at a fueling station. Next, chapter 7 is the chapter where you get into the requirements for the bulk gaseous storage, and this is going to be really one of the critical set of requirements at a fueling station because all these stations are going to have bulk gaseous storage of some sort. I'm not going to get into all the details of what's here, but I should mention that in this chapter there's a requirement for setback distances to various exposures, and this has been kind of a tricky issue for complying where you have stations going to urban areas where there's not a lot of space and they can't necessarily meet all the setback distances for their hydrogen storage. Next is the requirement that deals specifically with liquid systems. There's a whole new set of hydrogen fueling stations that are going in California. I think probably in the next couple of years, and they're all going to have liquid storage. So liquid storage is happening. Most of the initial stations that went in did not have liquid storage, but what's happened is there are more vehicles out there, and without having liquid storage, the stations don't have the capacity to fuel the vehicles that are out there. So it's a good thing to see this deployment advancing. Next, the chapter that is really the fueling station chapter, and that's chapter 10. That's where the core set of requirements are for hydrogen fueling stations, and it kind of lays out all the things about how the different pieces of the station have to work and how the dispenser has to work. I can't get into all that detail, but I would just want to mention a couple aspects of chapter 10. One is that there's a lot of requirements to deal with system shutdown and when you can start up a system after it's been shut down, and that's particularly important because what that means is if you do have a problem at a fueling station, it's going to shut down. It's very unlikely that you'd have any kind of large hydrogen release. Most likely you will just have a station shut down and in a situation where you have to bring that station back online. And next, there's several requirements that deal with maintenance of different components and systems at the station. This is important. I mention it because maintaining a hydrogen fueling station is really critical. Hydrogen, because of the high pressures, small molecule size, it likes to escape from wherever it's being held in captive. And as a result of that, you have to have a robust maintenance and leak management program to make sure you know what's happening at the station and you identify any problems and correct them before you have any kind of release. So now I'm going to talk about actually applying these requirements to a hydrogen fueling station. So I'll show you some pictures of the different pieces of a hydrogen fueling station. Most of these photographs are actually taken at NREL station, but these would look the same at a commercial refueling station. The only difference is there's a lot more space around the station than you would typically see at a station on a busy street. So you look at the station and you can break it down into the system components as storage, compression, cooling, and dispensing. And then there are cross-cutting aspects of this fueling station. There's sensors and alarms that kind of move across all these different components, emergency shutoffs, and process controllers to make sure that the station is operating within its required parameters. And I'm going to go through a little check sheet that I put together with the help of the National Park Service. This is for the Brentwood project, and it's not meant to be a comprehensive picture of what's in NFPA 2, but it pulls out some of the more important pieces of the code. And I put it in here. It may be helpful. I think Raul Castillo found it was useful for the Brentwood project. And then I'm going to talk about several of these items in the check sheet and show you some photographs. So we'll move along, but first we always start with the storage system. And what you see here is the nameplate on the hydrogen storage tanks that are actually at the NREL site here. And a key point is that these are ASME tanks, so they're designed to the ASME code, and then they have to be approved by the National Board for pressure vessels. So these tanks, to kind of put the different components in some kind of safety perspective, are extremely robust. The chance of having something go wrong with the tank, any kind of leak through the tank itself, is very unlikely. Next, when you look at these tanks, you have to look at this issue of setback distances from different exposures. And I pulled out some of the key exposures that are in the NFPA code. So those exposures are things like lot lines and air intakes, openings in nearby buildings. The basic idea is that if you do have a release from the system, that it's not going to get into the air intake of a nearby building, or it's not going to get past the lot line and have any safety impact. There's a feature of the code that I also want to mention. That is that if you're having difficulty meeting these lot line separation or lot line or other separation distances, there's a provision in the code that you can put a firewall between your system and whatever that exposure is and reduce the setback distances. And this, I mention this is because this provision in the code I think has been used in a lot of these California stations. So you have to have pressure relief with any high pressure system, and there are requirements for the pressure relief devices. And it follows that if you have pressure relief devices, you have to have an ability to get that hydrogen, if there's an overpressure, out into a safe location. So there are provisions for vent stack designs, and basic requirement is that you vent to a safe location that won't have any impact on the system or public safety. Next, a key piece of the system is a compressor, because the compressor is what gets this hydrogen, which may be stored at a low, like 3,000 psi, lower pressure, up to the pressure that's required for dispensing. And it's also because it has more moving parts really than just anything else in the system, and it's dealing with very high pressures, and it's dealing with hydrogen. We've seen that these compressors are one of the more vulnerable pieces of the system. They're more prone to breakdown. That doesn't mean that there's a safety problem. It does mean that the system gets shut down and you have to do repairs on your compressors. And we meaning NREL has a program for collecting data on these stations, and we've seen that compressors are an issue, and we're also looking at ways in which we can improve compressor performance. Next, you've got your hydrogen cranked up to the pressure you need, and you're ready to put it in a vehicle. At this is NREL station. Once again, we have the capability of dispensing both high and low pressure hydrogen. What that means is highest pressure hydrogen is 10,000 psi, and that's what's used in the passenger vehicles that are currently available now. The lower pressure hydrogen is 5,000 psi, and that's what's used in forklifts, and it's also used in buses. There are some fleets of buses operating out there now that run on hydrogen, and they typically run on lower pressure hydrogen. They don't have the same issues with fill time, so they can take their time in filling the vehicle. You also, as I mentioned, there's a chiller that's part of the system to get the hydrogen down to the. It may have to go down as low as -40 degrees, but by chilling the hydrogen, that allows you to decrease the fill time and get this fill time comparable to a gasoline vehicle. So this is a panel on the chiller at NREL, and it shows the electrical classification, because that is there are requirements that components within a certain distance from the dispenser meet electrical classification requirements. This is a Class 1, Division 1 chiller. Also on the dispenser, and this is similar to what's at gasoline stations. There's a breakaway device so that you can't have the nozzle in your vehicle and drive away. One thing I should mention is that when you have a hydrogen fueling nozzle connected to a vehicle, it's locked to that vehicle, because we're dealing with high pressures. It's not like a gasoline vehicle where you have the nozzle essentially just resting in the receptacle. The nozzle is locked onto the vehicle, because at that point the vehicle and the dispensing system are essentially one high pressure hydrogen system. So what that means is that when the vehicle is connected to the dispenser, the vehicle cannot be turned on. So it's very unlikely that you would have this breakaway device actually activated, because you'd have to somehow override some system to be able to even turn on the vehicle while it's connected to the fueling system. So these are some of the safety features, additional safety features at the dispenser. You see there are bollards to protect the dispenser from being hit by vehicles. There's a manual shutoff on the rear side of the dispenser, so you can completely shut off the system. There's emergency power off that shuts off the dispenser that's located, one at the dispenser, and then there's one at a safe distance from the dispenser. So there are a lot of safety features. Some of them can be manually activated. Others are passive safety devices. Next, I want to spend a few minutes talking about there's the really extensive set of permitting resources and tools that have been developed to help people who may have to do or review one of these projects. The first, and these tools are all available at the web link that you see at the bottom of the page, that H2 Tools. And the first tool I'm going to talk about, I really encourage people who have to review one of these projects or are going to develop or in the position of being a project developer, to take a look at this permitting video. NREL worked with the Orange County Fire Authority in California, which has done more permit reviews for hydrogen fueling stations than any jurisdiction, to develop this video, and it really gives people kind of a quick orientation on what a fueling station is and what some of these safety issues are and what the code requirements are. There's also online code official training. There's a whole series of NREL technical reports that kind of drop into several levels of detail beyond the video. And then there's a national permit guide for hydrogen fueling stations. And then there's a permitting website that has really detailed code citations for both hydrogen fueling stations and other technologies such as stationary fuel cells. So there's a lot of information out there, and it's deliberately designed to go from the kind of orientation piece of information or tool down to a fairly detailed tool. So it's meant to address the needs of all users, starting from someone who's just getting introduced to this technology to someone who's actually done several permit reviews or developed several projects. So the message is there's a tool for every user, and it's all available. The video I mentioned was done in conjunction with Orange County. Got to give special thanks to Carl Rivkin. He was the fire protection engineer who is the primary driver in this project and is the host for the video, and I encourage you to take a look at this if you're in a position of having to do a project. And there's also an updated version of this code official training course. It's an online training course. It kind of walks you through both the basic safety issues of the technologies and the code requirements. It also has a wealth of links to all kinds of information, all kinds of resources. So it's really very handy, and can once again can be used at different kind of depths. From just, you can kind of cruise through this, or you can go to and check out all the links and get all kinds of information on hydrogen properties and projects. So in conclusion, I just want to make a few points, and then we'll open the line up for questions. DOE has supported the development of really a comprehensive set of codes and standards to permit hydrogen technologies, including fueling stations. So this has taken place over a period, almost 15 years. So these requirements are out there. They are now actually being, in a lot of ways, field tested by the stations that are being put in now, but they exist. So you're not confronting a situation where there are no codes to address these technologies. The center of these codes and standards centerpiece is this National Hydrogen Code, NFPA 2. So you don't have to wade through, and there are quite a few other documents that are connected in here in some way. You don't have to wade through all these other documents to get started. You start with NFPA 2, and then that will point you to all the other documents that may be a part of the project review. And once again, why is this a concern? There are thousands of fueling stations that must be built to support the commercial deployment of fuel cell vehicles, and that deployment is happening, and it's being driven by major forces that aren't going to go away, such as air pollution and the need for using clean, renewable energy technologies. So also, last point, DOE and NREL have developed a really comprehensive set of permitting tools to complement the codes and standards. So there's a lot of information out there. I sometimes tell people that there's probably more permitting tools than there are fueling stations right now, but I think that will change. So the basic point, though, there's a lot of information out there. It's not like you'll be starting with nothing if you have to do one of these projects. And with that, once again, I want to thank Federal Energy Management Program for supporting this webinar. And I will stop here and see if we have any questions. Thank you.
Okay, please turn your attention to the chat function if you'd like to ask any questions at this time, and I will read them out to Carl. So Brian Olson says NFPA 2 is available online for any NPS employee. James Henash says, are there any certification courses that can aid with this?
The question is, are there, first, someone pointed out that NFPA 2 is online for the National Park Service, which is great. I also should add that NFPA has made NFPA 2 online for free, but it's in a format where you can't print it, so it is somewhat limited. As far as certifications, there are different certifications that may apply to this. They're not hydrogen-specific certifications, but there are some there's some broad safety certifications, but there's also some fire safety certifications that are offered through the National Fire Protection Association that would be relevant for someone who's doing plans review, fire safety plans review. They are not necessarily, I shouldn't say not necessarily, they're not hydrogen specific. However, we have developed this online training course, and if there is interest, we can take that a step further and develop, look at working with some of our partners to develop a certification. I also should mention that on the vehicle side, where there's a need for repairing these vehicles, there's an interest right now, and I think there's a program in one of the community colleges in Los Angeles where they're going to develop a certification for technicians for repairing the vehicles, and they're also looking at then expanding that certification program so that there would be certified technicians for installation and maintenance of high-pressure hydrogen fueling systems. So the certification process is just really begun now because we don't have that many stations, but I would expect as commercial deployment increases, there is these certification programs that are just developing will expand into real programs that are widely available, not just at one community college.
Okay, we have another question from Dante Perry. How does the cost of how does the cost of a hydrogen project compare to the cost of constructing other fuel projects?
Yeah, that's a good question. How does a hydrogen fueling station compare to a gasoline station? And it's right now I don't have that precise data comparing the two, but I think it's I think it's safe to say that the hydrogen fueling station is a more complex technology than a gasoline station, because you don't have this high pressure gas storage and this compression portion in a gasoline station. So the hydrogen fueling station is a more expensive technology, and there's probably, at least right now, the maintenance costs for a hydrogen fueling station are going to be higher than that for a gasoline station. I would expect, as the technology becomes more standardized and some of these sort of optimization issues are addressed, that the cost of maintenance for hydrogen fueling stations will drop considerably.
Russell Moore is asking if the slides will be available after the presentation.
Yes, they're going to be posted both, and correct me if I'm wrong, Molly, there's a FEMP location, web location, but they're also going to be, I think I put it in one of the slides. There's a web link. They're going to be posted at the H2 Tools website also. So by next week, these slides will be posted, and they will be available for use.
Okay. Juan Antonio Roldan Garcia wants to know if the NREL financial tool is reliable and how good is our approach.
Can he tell me the financial tool that he's referring to?
I'm not sure.
There are several NREL financial tools, so that's what I'm wondering if you can give us a little more information about the tool that you're referring to and what it is intended to do.
While we're waiting for follow-up from Juan, Raul Castillo said the NFPA 2 can be available to NPS employees by contacting their regional fire managers.
Okay. Well, thank you, Raul. So you have a variety of ways to access NFPA 2, which is good, because the online access, although you can see the whole document, is a little bit awkward to use. And as far as the NREL financial tool, I know that I'll try to answer the question, is that NREL has developed several financial tools, both for estimating costs of stations and cost of infrastructure beyond stations. I'm not an expert in those tools, so I don't want to give anyone any misleading information, but what I can do is refer the question to Mark Molina, excuse me, who is the NREL project manager who has done that development for that tool, and he could give you a much better answer than I can.
I'm not seeing any other questions at this time. We'll just give you one more minute. If you want to ask anything else, use that chat tool to type in your questions, and we'll try to get those answered for you.
While we're waiting to conclude, I just want to emphasize that if you do have questions, and typically when I listen to a presentation, the questions don't occur to me till the next week or some other time, and please send the questions in. We'll get them answered one way or another. And also, please look at us as a reference for this information on this technology. That's what we're here for. We're here to get you the information you need. So don't look at today as necessarily the end of the process. I hope that there are a lot of projects that appear, and we're able to help you in some way with those projects.
We do have another comment from Brian Olson, who says the NPS version is a download PDF file you can store on your computer or print out.
Well, that's good, because that gives you a searchable file, which I find very handy. So you will have access to that PDF. And with that, I want to thank everyone once again for joining us today in this presentation, and just reiterate what I've said before, is that please look at us as a resource for information on this technology. And even if you have a question that doesn't seem directly related to what we talked about today, we can probably connect you with someone who can answer your question. And with that, I'll say thank you very much.
Thank you, everyone. Please send any follow-up questions to Carl at the email address on your screen, and we will follow up with the links within the next week. Thank you.